Welcome back, everyone. Today we're diving into a question that's both ancient and incredibly relevant. How did humans develop language?
It's a real mystery, isn't it?
A huge one. And we've got this awesome stack of sources to help us try to crack the code. We're going all the way back to Darwin and then forward into some cutting-edge linguistic research.
Oh, wow.
Should be a fun ride. You ready?
Absolutely. Let's dive in.
Right. So our sources take us right to the heart of Darwin's work.
Yeah.
It seems he was captivated by language, like right from the start of his research on evolution.
Oh, for sure. In his early notebooks and in The Descent of Man, he brings up language constantly. You can really see that he saw it as this crucial turning point, what set humans apart.
And I found this quote, get this from Darwin's notebook, he writes, "He who understands baboon would do more toward metaphysics than Locke."
Oh, wow. That's a statement.
I know. What do you make of that?
Well, it shows you, I think, how much Darwin believed that to really get the human mind, you got to study primates. He's saying, look, if you can figure out how a baboon thinks, how they communicate, you're going to unlock something really profound about human thought and language.
So it's not just about comparing like brain size or anatomy.
No.
It's about understanding those deeper complexities.
Yeah, those social and communicative complexities. How do we get from there to language? In Darwin, he even took it a step further.
He did.
He did. He speculated that song, like a very basic melody, might have been that evolutionary ancestor to language.
Oh, so like instead of the grunting caveman, we've got singing primates.
Exactly. He thought that being able to sing emotions, to sing intentions, with all those changes in pitch and rhythm, that would have been a huge evolutionary advantage.
Okay, yeah, that makes sense.
So maybe our ancestors weren't just grunting, but they were seeing their way to more, sophisticated communication.
I love that. That's a beautiful image.
It really is.
Okay, but now our sources bring in this other potential stepping stone.
Yeah.
Mimesis. Can you unpack that for us?
Sure. So mimesis, it's basically acting things out. Think beyond simple gestures, though. It's a much richer way of representing events or emotions, maybe even abstract ideas, all through body language, facial expressions, vocalizations.
So like a primitive form of storytelling where your body is the canvas.
Exactly. And here's the thing. We see evidence of mimetic abilities in apes, which suggests this kind of communication might be really, really old, predating spoken language.
So we're talking potential progression here. Basic gestures to elaborate mimes, and then finally, boom, full-blown language.
Could be, but there's a big difference between how apes communicate and our languages.
Oh, totally. Apes are smart, but...
Yeah, they are, but their systems, they don't have the same symbolic and grammatical complexity that human language has. Their mimes, they're very tied to their immediate experiences, not as abstract, not as flexible as ours.
Right, so mimesis may be a crucial step, but symbolic language, that was the real game changer.
Absolutely. That leap to symbolic representation, it just blew the doors wide open. It let us talk about the past, the future, share complex ideas, build complex societies. I mean, look at us.
Yeah. Okay, so we've gone from grunting to miming to talking. But then how come language isn't perfect? I mean, if it's so advantageous, why are there things like irregular verbs?
Oh, the paradox of irregular verbs.
Right.
It's a puzzle. And Steven Pinker, he offers a few possible explanations in our readings, but honestly, each one just raises more questions.
Well, let's hear them. Hit us with those Pinker theories.
Okay, so one idea is that there's some hidden trait, something about all irregular verbs that linguists just haven't discovered yet.
Yeah.
And maybe children intuitively grasp this trait, so it makes it easy for them to learn these exceptions.
It's like a secret code in the irregular verbs that we, like as adults, we've lost the key to.
Maybe. Or another idea is that maybe the rules of language, they're actually more flexible than we think. Maybe these irregularities stick around because language, it has to adapt. It has to be able to bend and change.
So it's not this perfectly logical system, but something more fluid, more dynamic.
Exactly. And then there's a third possibility. What if the rules are actually more limited than we realize?
Okay.
And children, being amazing learners that they are, they figure out these limitations as they learn language.
So the irregularities, they're not so irregular after all. Just reflections of rules that we haven't fully figured out yet.
It's possible. And really, the whole thing, it challenges us to think differently about language, about learning, about the human mind. Like, what are we missing?
Yeah, big questions.
Huge. It really makes you think, huh?
It does.
And speaking of things that make you think, you mentioned symbolic reference earlier. And In our sources, they use this great example, the word Gavagai.
Oh yeah, the Gavagai problem.
Right.
It's the perfect way to show just how amazing it is that kids learn to speak at all.
It really is.
I mean, you hear a word like dog, right? But how do you know that means the whole furry creature, not its tail, not its bark?
Right. Like imagine you're an anthropologist, and you meet this new tribe, and they point at a rabbit and say, Gavagai.
Gavagai.
How do you know what that means? The whole rabbit, just the fur, the hopping, something else entirely.
Yeah, it's mind-blowing. And it makes those irregular verbs seem kind of easy in comparison.
Yeah, maybe.
So how do kids crack this code?
Well, our sources suggest that it's all about constraints. Constraints on how we form concepts.
Okay.
Basically, our brains aren't just empty containers, We're not just passively absorbing every word we hear. There are these built-in biases, these assumptions that help us narrow down all the possible meanings.
So we kind of come preloaded with these ideas about how the world works, and that helps us learn language.
Exactly. Think about it. If a kid considered every single possible meaning for every word, learning language would be impossible.
Oh yeah, for sure.
Imagine trying to learn dog, but also undetached dog parts or dog-shaped cloud.
Okay, yeah, that makes sense. We need those constraints. But where do they come from? Is it all in our minds, or is there something physical going on in our brains?
Well, that takes us into the world of the brain, and specifically this thing called brain lateralization. You might be surprised to learn that most language processing happens on the left side of the brain.
Whoa, so I have these, specialized areas in my brain just for language.
You do. Two key areas are Broca's area, which is all about producing speech, and Wernicke's area, which is about understanding what you hear. And if these areas get damaged, it can cause really specific language problems.
So, if someone has damage to Broca's area, they might understand what you're saying, but can't really form their own sentences.
Right, and with Wernicke's area, it might be the opposite. Fluent speech, but it doesn't really make sense.
Wow, that's fascinating.
It is. But, and our sources point this out too, it's not quite as simple as we used to think. Yeah, it's not this one-to-one mapping. Neural networks, they can reorganize, if there's damage or even with stimulation. It makes it hard to say, this area does exactly this.
The brain's adaptable, huh?
It really is. It's amazing how plastic it is. And there's actually research on agrammatism in different languages.
So agrammatism?
Yeah, it's basically when people have trouble with grammar. And what they've found challenges that idea of a fixed grammar module in the brain. It seems more like language involves this whole network, not just a few isolated areas.
Wow, okay, so much more complex than I realized.
Yeah.
So we've got these brain regions, but we can't forget about writing systems.
Right.
I mean, think about it. For most of human history, we were purely oral.
Huh.
So how did inventing writing change things?
It was huge. Writing has definitely transformed how we think and how we communicate. From earliest pictographs all the way to the alphabet, the evolution of writing systems has totally revolutionized how we store and transmit information.
Yeah, and you've studied the evolution of writing systems a lot, right?
I have. It's fascinating.
What are some of the ways these changes have actually impacted how we think?
Well, I think the phonetic alphabet was a real game changer. It just made it so much easier to connect those visual symbols to sounds, made literacy way more accessible. And that might have even influenced, how we developed abstract thought and reasoning.
It's like going from, I don't know, a really clunky old computer to something super fast.
Yeah, good analogy.
But it's interesting, though, right, that spoken language was around for, thousands of years before we had writing?
It was.
How come speech was enough for so long?
Yeah.
And what finally made us need writing?
Well, spoken language is incredibly powerful. It's adaptable. And for a long time, it met all our needs. Writing, though, it's cognitively demanding, right? And you need the technology for it. It probably emerged when societies got more complex. And they needed a way to keep records, to trade, to govern, all that stuff in a way that was more durable, more transportable.
So it wasn't just a random invention. It was driven by these very specific needs.
But it seems that way, yeah.
It makes you wonder what other forms of communication might pop up in the future as technology keeps evolving.
Oh, for sure. I mean, what about virtual reality? Augmented reality. What if we have brain-computer interfaces? Could those lead to totally new ways of thinking and communicating? Ways we can't even imagine right now.
That's kind of wild to think about.
It is.
Okay, so we've covered a lot, from the origins of language to how our brains work to this huge impact of writing. But there's one more piece I want to explore, coevolution. This idea that the human brain and language, they evolved together.
Right, like a two-way street?
Yeah. So how did that work? What were the changes in the brain?
Well, our sources point to the prefrontal cortex.
Mm-hmm.
That's the part of your brain that's all about planning, decision-making, working memory, all those things you need for language. And it got bigger, more powerful.
So a more powerful prefrontal cortex, that's what gave language the space to really take off.
Exactly. And we can't forget about the vocal tract.
Oh, right. Like from grunting to singing to speaking.
Yeah. Our sources specifically mention the descent of the larynx as a crucial step in all that.
Okay, I remember reading about that. How did lowering the larynx help?
Well, it basically made our vocal tract longer, gave us a bigger resonating chamber so we could articulate sounds more precisely, produce a wider range of sounds. Basically, it gave us the tools we needed for complex language.
It's like evolution was saying, hey, a lower larynx might make you choke easier, but hey, articulate speech is worth it.
Uh-huh. That's one way to put it.
So the benefits of being able to communicate better, they outweighed the risks.
It seems so, yeah.
It's amazing how language shaped us right down to our anatomy.
Mm-hmm.
And this brings us back to Baldwinian evolution. I gotta be honest, I'm still wrapping my head around that one.
It's a tricky concept.
Can you explain it in a way that even I can understand?
I'll try. Okay, so think of it this way. Imagine a learned behavior, something like mastering a language. And let's say that behavior helps you survive, helps you reproduce, right? Over many generations, the genes that make it easier for you to learn that behavior, those genes are going to become more common.
So, like, our ancestors who were better at language, they had an advantage, and they passed that down to their kids, making it easier for them to pick up language too. So our struggle to develop language actually changed our genes.
Exactly. That's the idea behind Baldwinian evolution. Learned behaviors, over time, they can actually affect our genes. Pretty cool, huh?
Yeah, really cool. Okay, so we've covered a lot in this deep dive, from the very beginnings of language to how our brains process it to how language has actually shaped our evolution. And somewhere in the middle of all that, we've got these fascinating little quirks, like those irregular verbs, still puzzling us.
They really are puzzles, aren't they? They remind us that language isn't static. It's not perfect. It's constantly changing, adapting.
It's like they're these little time capsules from the past, you know?
Yep.
I like that. Yeah, time capsules. They show us that language, it's not just one thing. It comes from our biology, but also from our cultures. This mix of like built-in stuff and just things that happened along the way.
It's been a wild ride, this deep dive.
Mm-hmm.
Really makes you appreciate how complex language is.
For sure.
It's not just about talking to each other. It's really a part of what makes us human.
Totally agree. It's shaped how we think, how we see the world, how we build societies, even our bodies. Like, it's woven into everything.
And it makes you wonder, right, what's next for language? We talked about how writing changed things, but now with AI, with all this new tech, who knows what's coming?
Exciting, but also a little scary, right?
Totally. Could AI create new languages we don't even get? What about brain-computer interfaces? Will we even need to talk anymore?
It's like we're at the beginning of a whole new chapter in the story of language, and it's not clear what our role will be in writing it.
Big questions. So as we wrap up this deep dive, what's the one thing you want our listeners to walk away with? What should they be thinking about?
I'd say remember how powerful and complex language is. It's so much more than just words. It's a way to peek into the human mind. It shows us where we came from, and it's shaping our future individually and as a species.
Well said. We've come a long way today, from grunting primates to Shakespeare.
Yeah.
Explored those crazy networks in our brains, and even peeked into the future of communication in this high-tech world. This has been quite the journey.
It has. It's been a pleasure diving into these questions with you.
Likewise. And, as we finish up, I'm reminded of this quote by Edward Sapir, the linguist. He said, "Human beings do not live in the objective world alone, nor alone in the world of social activity as ordinarily understood, but are very much at the mercy of the particular language which has become the medium of expression for their society."
Yeah, that's powerful. Language shapes our world, and as language changes, so does how we understand ourselves and the universe.
So much to think about. To everyone listening, keep exploring, keep asking questions, and keep being amazed by this incredible thing we call language. Until next time, happy deep diving.